the 21st century, laced with state-of-the-art industries, majestic architectural wonders, rocket-fast automobiles, and enormous skyscrapers. It is hard to imagine our world without the magic of metal, without the magic of steel. So how has this wonder or super metal come into existence? And where does it really get made? The answer to this lies right here, beneath the ground and in the pits of fire. Steel, a hard, strong grey or bluish-grey alloy of iron with carbon, found in the very ores of our planet, along with other usual elements such as manganese, chromium, etc., is the most extensively used metal in our planet, having its origin from a very huge hot oven called as the blast furnace. The blast furnace, which gets its name from the method that is used to heat it, is a large steel structure lined with refractory fire bricks that can withstand temperatures approaching 2000 degrees Celsius. Although the origin of the blast furnace dates back to Han China in the 1st century BC, it was in 1709 that Abraham Darby developed a blast furnace that could be fired by coke instead of charcoal, which paved the way for modern-day blast furnace. Traditional blast furnaces are chimney-like structures which are actually 80 to 100 feet wide and 30 meters high, made of iron or steel and used chiefly in the process of smelting, that is, deriving a metal out of an ore, in this case steel out of iron ore. The principle involved in this means of extracting metals is that of the reduction of the ores by the action of carbon monoxide, that is, the removal of oxygen from the metal oxide in order to obtain the metal. Lined with fire brick, the furnace is narrow at the top, increasing in diameter downward, but narrowing again suddenly almost at the bottom to form the hearth or crucible where the fine molten products are caught. The furnace is fed from the top, which has an entry referred to as the charging hole, with a charge of definite quantities of ore, coke and flux, consisting mostly of limestone, that is carried over the charging ramp. Water is then released, which travels through one end of the water channel and pours down from the other end, hitting the water wheel, which acts like a turbine. The water wheel starts rotating due to the pressure and the flow of water, causing the mechanism of cams to also move, eventually striking the tuyeres to bellow instantaneously. Thus, preheated compressed air is introduced at the bottom through tuyeres, entering just above the crucible. The air passes upward through the charge, where coke is burned to form carbon dioxide and heat. The heat decomposes limestone into calcium oxide and additional carbon dioxide. Carbon dioxide oxidizes coke to form carbon monoxide at a high temperature of 1200 to 1300 degrees Celsius. The carbon monoxide then reduces the ore to iron, taking on oxygen and reverting to carbon dioxide. This gas, together with unused carbon monoxide, nitrogen and other constituents of the air originally introduced, is let off through a pipe from the top of the furnace, and being still at a high temperature is employed to heat the stoves into which fresh air for the process is brought. As the operation proceeds, the mass in the furnace becomes molten and descends into the crucible. The iron sinks to the bottom. Impurities, called the slag, being lighter, float on the top. The slag is drained through a pipe in the upper portion of the crucible, which is called the slag pipe. The iron is tapped from below and is run into sand molds to harden. The product is known as pig iron or cast iron, and the place where it is hardened is referred to as pig iron bed. Thus, we now know the secret behind the origin of the miracle metal called steel that has practically shaped our civilization and way of life, from cars to cranes and bridges to buildings.